Hello and welcome back. And in this video, we're going to be looking at another interview question, basically for linked list. And this time, we're going to look at reversing linked list. Okay, so basically, the problem is that's given to us is basically we have a linked list 1, 2, 3, 4, 5, and what we need to do is we need to reverse it and print 5, 4, 3, 2, 1. Okay, so that's the question in hand, and what we need to do is basically we need to figure out a way, an algorithm, basically to reverse this list. Okay, so a couple of things you can actually think about is, I mean, first, if you want to bootstrap, I mean, just to bootstrap the idea, then you can think about like how you can uh, very simply basically reverse a linked list. So you can maybe um, take the linked list, like read all the links, put it in another array or something, and then reverse it and put it back in the linked list, right? So that could be one solution. But think along along those lines and see if you can come up with a better solution. I mean, that's one solution, but like try to come up with a better solution and see if that solution that we discussed helps build up your build up the idea. So hint is that this is possible in one iteration without using any extra memory and basically just having to loop through what we have done while inserting or deleting elements and stuff like that. Okay, so that's the hint. So take a pause here and I mean pause this video and then try to attempt to basically build something out and come back to see the solution that we've got for you. All right, so pause the video here. Hope that went well. So let's go ahead and take a look at the solution that we have got for you. So this is a linked list that you've been given 1, 2, 3, 4, 5, right? And what you can do is, like we discussed, like during the problem statement slide, that we can have an array and basically iterate over the list and store all the elements into the array and then reverse them and put them back into the linked list. Well, that's not a bad solution. First of all, when you're in the interview, the first thing to do is to solve the problem with a naive approach. Like any approach that you have in mind, solve the problem with that, and then try to optimize it. Or you can run it by the interviewer, saying like this is what I'm thinking, and this is one potential solution. But I see like this time complexity and the space complexity is going to be high, so I'm actually thinking about another better solution, and so that way interviewer at least knows that you have a solution in mind, and if they ask you, hey, let's put the naive solution in place, at least to bootstrap the concept and like know what you have, you figured out and understood the problem correctly. That way, if there is a misunderstanding in understanding the problem statement, then they'll actually point it out. Okay, sometimes they do that, and sometimes all they're looking for is like your ability to solve the problem, like and then work out a solution after the naive approach is done. Okay, so just an FYI, another interview tip. Okay, so going back to the solution, so we have this list 1, 2, 3, 4, 5, right? And our head is pointing to 1 and 5 is pointing to null. That means that's the end of the list. Now what we can do is we can iterate over this array, this list, right? And in this list, what we can do while we are iterating over, we can start reversing the pointers. So 1, instead of pointing to 2, it will point to nothing, and 2 will point to 1. Okay, and similarly, then like 1 is pointing to null, and then 2 is pointing to 1. and then we flip the next one, we flip the next one, and we flip the next one. And just flipping all these pointers, we can basically achieve a reversed linked list. And at the end, we update our um, head pointer to point to the last element in the last link in the input linked list, and is now head of the output linked list. Okay, and we actually just print it out. So we simply traverse and print it out. Okay, so hope that made sense. Once again, what we are doing is we are taking our list, we are iterating over, and each iteration we are going to keep track of current element, next element, and previous element, right? So we can actually take our current element and first check if it's nil. So it's going to be nil basically when you have head pointing. So basically current element, if it's nil, that means like, that's the end or list is empty. Right. That's out of the way. Now, when you start, your current element is 1, right? So what you're going to do is you're going to say current dot next, put it in next variable, okay? And then basically point current dot next to the previous element. Now, previous as we define, we're going to define it as nil. So this will start pointing to nil, okay? Then what we're going to do is we're going to say current becomes the next that we have cached, and previous becomes the current, right? So if we first say previous is equal to current, that means 1, and then next becomes your current, which is 2. So we are in the second iteration now. So then we actually say 2, point to 1, and then cache the 3 and make 3 as current, and so on and so forth. Okay, that way you're going to basically reverse the entire linked list in one go. All right, so I know that's a little bit confusing, so let's go ahead and take a look at the example, and it's going to make things much more clear. So let me run this. What we have here is that we are printing 1, 2, 3, 4. So we have 1, 2, 3, 4, right? And I'm going to print in line here. That way, like, we know the separation where where this list ends. Now we're going to write a function here, reverse list. Okay, it does not take any parameters, so we're going to use this list for our example. You can take it as a parameter. It doesn't matter. And then what we're going to do first, like I said, we're going to say current, and we're going to say current is list dot head. Okay, so head is our current when we are starting. Then we create two nodes. One is next, optional, and another one is previous, optional. Okay, and we say while current is not equal to nil. So if the list is empty, it's gonna end right there, right? And then we say now this is where we need to actually start changing our pointers. So first, we're gonna basically cache our next item. So if you recall again in this example, we need to, so next for the current item, that is 1, it's pointing to 2. So we need to cache this, right? So we're gonna say next is equal to current dot next, okay? And we know it's not nil, so we can force unwrap that. Now, next thing is we need to update our previous. So, sorry, we need to update our current dot next. Okay, because we already cached the next, so we can safely update current dot next. Okay, so current dot next is gonna point to this guy. There's nothing here, so that's when this is gonna be nil. Okay. Then we say our previous is current. So the new previous becomes the current element, right? So this becomes the previous for this guy, right? Because that's the next step we're gonna do. We're gonna say, and the current is the next that we cached. Okay. So this gives us all those pointer chains. pointer changes. So next is what we cached first. So we can update the current dot next to previous. Okay. So let's imagine if you're sitting here at 3, right? So at 3, the previous is going to be 2, and next is going to be 4. Okay. So we're going to say next is equal to current dot next, that's 4, and current dot next is previous. So we flip our pointer here. So we say current 3 dot next is previous, that is 2. So we flip our pointers here, and then we say previous becomes new current. So we are now preparing to go into the next iteration. So we say previous, that's previous, that was earlier 2. Now it's basically it's overridden by current, that is 3. So we say previous is equal to current, that is 3 now, and the current becomes the next one that we cache. So current becomes this one, this guy right here. So we can go into another iteration, another loop. Okay, and at the end, we're gonna be left with so we're gonna be left with 5, right? So 5 is pointing to all the elements. So technically, this is now our head. Okay, so this is going to be the previous value for next one, because next item for the current is going to be nil. So only previous is going to have like value populated. So we're going to say at the end, list dot head is now previous. Okay, so whatever was in the previous, and at the end of the loop, previous is going to point to this 5, the last element. Okay, and now our list is basically reversed. So if you call this and call list dot print list, like so. Now if you run, all right. So what did we do? Okay, while. All right. So unused identifier reverse list. What? Oh, okay. Of course, because it needs to be defined down here. Okay. All right. So there we go. We have 1, 2, 3, 4, and our reverse linked list is 4, 3, 2, 1. All right. So that's how you actually reverse your linked list in one iteration. Once again, the time complexity for this one, because we are just iterating over this list once, is going to be O of n, or the size of the list. So yeah, this is your interview question, reversing linked list in one go. So hope you guys like this video, and thanks again for watching. I will see you guys in next video.